So here what is our interest? We are interested to find marginal role of xj on y in the presence of other xj prime variables. Okay, so what do? First, step 1 is we remove xj and regress y on all but xj variable. Okay, and then we name it as xij y, this residual from this model. Okay, so that would be yi minus yi hat when we are excluded xj. This is step 1. Step 2 will be what? Step 2 will be we'll regress xj on xj prime. Okay, and the residual from this model will be eij y eij x will be xij minus xij hat. Alright, and then what do? We plot this eijx versus eij y, and we get this as a, if we get this line, then slope will be equal to beta j. Alright, and then here it would mean that if there is less scatter, then the relationship is strong. So these will then be my partial residuals which scatter along this line y equal to beta x, and if we find less scatter, then we can say that okay, even in the presence of other variables there is a strong relationship between xj and y. Okay. So with that we move on to solve a few problems for this session. Now, question number 1, HII is a measure of distance between x value for the ith case and the origin. So, what is that? Mean of x values for all n observations. That is the central value for x. Okay. So, this answer is A. Moving on. So, let Ri be the ith studentized residual and Di be the ith standardized residual. If I is an influential observation, then Ri less than Di or Ri greater than equal to Di, or we cannot say. So, let me just first write down Ri. Ri is Ei by root over ms residual 1 minus Hii, and Di is normal. This is actually studentized and this is standardized. Root over ms residual. Okay, and we know that the ith observation is influential. So if it is influential, it will have unusual x and it will have unusual y. So Hii will be close to 1. So then this one will be close to 0. Then what do we have? We will have mod of Ri as greater than Di, greater than or equal to Di. Is it okay? Fine. So then answer will be B. Alright, moving on. Yes. So moving on. What does the plot of Ei versus Yi have as a slope? Okay. So we can write Ei as beta naught plus beta 1 Yi plus epsilon I. This is the Ei versus, so this is Ei and this is versus Yi. So this is the model that we would want. So then beta 1 hat will be how much? It will be summation of Sxy, here x will be Ey by Sxx, so that will be Syy. Okay, so this one we can write as summation Ei minus E bar to Yi minus Y bar divided by summation Yi minus Y bar whole square. Okay, so then this will be E bar is 0, so this will be summation Ei Yi minus Y bar by SST. Okay, so then Y bar, if it comes out, summation Ei is again 0 because E bar is 0. So then this thing actually becomes summation Ei Yi by SST. Alright, so then this becomes, we can write as Y transpose E by SST, because this is summation Yi Ei can be written as Y transpose E. Now E can be written as Y transpose I minus Hy by SST. Okay, since I minus H is also idempotent, we can write it as Y transpose I minus H into I minus H Y by SST. That we can write as, since I minus Hy is E, we can write as E transpose E by SST. So this is what? SS residual by SST So which is 1 minus SS regression by SST, which is nothing but 1 minus R square. Therefore, slope of EI versus YI is always going to be 1 minus R square. Is it okay? Okay. So moving on, let's find out. Let's consider the data below for the model this thing. Okay, and what is the value of H22 equaling? So X will be how much? So alright, so the X matrix here is 14, 25, 19, 32, 12, 22, 11, 15, and we have an intercept, so here we'll have 1, 1, 1, 1. Alright, so this is my X matrix. Now we'll have to find out X transpose X inverse. So that would be X transpose is what? 1, 1, 1, 1, 14, 25, 19, 32, 12, 22, 11, 15. Okay, transpose again 1, 1, 1, 1, 14, 25, 19, 32, 12, 22 and 11, 15. Okay, so we'll find out X transpose X inverse. So let me just do it. So here we have X equal to matrix, we'll just enter C 1, 14, 25, 1, 19, 32, 1, 12, 22, 1, 11, 15. We'll give by row equal to true, n row equal to 4, n col equal to 3. Let's see if the matrix is created properly or not. Yes, the matrix has been created. Now X transpose into X is how much? This is this value, 4, 56, 94, 56, 822. So I'll just write it down over here. So X transpose X will be 4, 56, 94, 56, 822, 1387, 94, 1387 and 2358. So this is X transpose X. Now we have to find out X into X transpose X inverse X transpose. So I'll just find it out. So this will be X into, let us write this as A, into to solve A, that would be X transpose X inverse into X transpose. So then what do we have? This is actually my H matrix. Okay, so H will be this thing. Alright, so from here we find this is actually my H matrix. Okay, this is equal to H. Now what do we have to find out? We have to find out the value of H22. So H22 is this one, 0.9512. So H22 is this thing. Alright, moving on. The second standardized residual D2 is approximately equal to what? So D2 is actually E2 divided by root over ms residual. Okay, so now we have to fit this model. So let's do that first. In order to find E2, we need to first get beta hat and beta values. So how do we do that? Let us first fit the equation. So we have X transpose X inverse as this matrix. Okay, so X transpose X inverse into X transpose Y. So that would be, so beta will be X transpose X inverse into X transpose into Y. Now what is my Y value? Y value is this thing, 301, 327, 246 and 187. Okay, so then beta hat will be this thing. From the above equation we have beta hat as 80.93 minus 5.84 and 11.325. Okay, so then E2 will be Y2 minus Y2 hat. So that will be what? So y hat is actually x into beta hat. So then y hat will be x into beta. So y hat values then become this thing. So y hat is actually 282.23 or 24 rather. Y2 is 332.29, Y3 is 259.95 and Y4 is 186.52. Okay, so E2 will be what? E2 will be Y2 minus Y2 hat. Now what was Y2? Y2 was 327. So E2 will be 327 minus Y2 hat was how much? 332.29 divided by root over ms residual. Okay, so how do we find out ms residual? Ms residual is nothing but ds residual is nothing but ss residual by df of the residuals. Okay, now here we have y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus epsilon, 2 x's and 1 y. So and 3 parameters of interest. So df of residuals would be n minus 3. And how many observations do we have? Here we have n equal to 4, so df will be 1. Therefore ms residual will actually be equal to ss residual. Alright, now ss residual is how much? This is summation ei square. So once we have our yi hats, so we can easily calculate the ei. So ei will be y minus y hat. Okay, so once we have our eis, then summation of ei square gives me 574.8896. So SS residual is actually 574.8893. Therefore D2 will be E2, which is 327 minus 332.29 divided by root over 574.8893. This is how much? This is 327 minus 332.29 divided by square root of 574.8893. So this will be minus 0.22. Alright, then moving on to the next one. So here they are saying you have to consider the same data. The second studentized residual is approximately equal to how much? So then R2 will be E2 by root over ms residual into 1 minus hii. So hii was how much? This is d2, so this will be h22. So h22 was 0.95. So then this will be d2 minus 0.22 divided by root over 1 minus 0.95. So it will be 0 minus 0.22 by root over 0.05, which is equal to so this will be d2. So r2 is actually d2 by square root of 1 minus 0.95. So that will be minus 1. Alright. So then this is the answer. It will be minus 1.0016. 00 something. So then this becomes minus 1.0016, and that's the answer. Alright, moving on. Consider the data in problem 5. The second press residual is approximately equal to how much? So in order to find out the press residual, we have to remove this second observation and then calculate. But by the formula that we have that relates press residuals to usual residuals, we can easily find out how much is E2. So that will be E2 by 1 minus HII, and E2 is how much? E2 we have found out is 327 minus 332.29. So this will be 327 minus 332.29 divided by 1 minus HII is how much? 0.95. So this amounts to how much? 327 divided by 0.05. So this is minus 107.8. So this is the correct answer. Okay, so moving on. The question is the plot of EI phi versus EIX always has a slope of size what? Now let us write the X matrix as x1, x2, xj to xk, let's say, and a 1 vector. So let us have a k plus 1 cross let us have a n cross k plus 1 dimensional X matrix. Okay, now if we have this model, let's say y equal to x beta plus epsilon, okay, then we can decompose this and write it as y equal to xj beta j plus xj beta j, where beta j is actually beta 1 beta j minus 1, beta j plus 1 to beta k, beta naught. Okay, so this is actually my beta j, excluding the beta j variable, and xj is also that corresponding x matrix where the jth column is not there. Okay, so this one is actually n cross k. Okay, plus epsilon. Alright, now if I consider only this part, alright, and I consider the regression that y regressed on all but j, then the corresponding hat matrix for this regression will be hj, and that will be xj into xj prime xj inverse into xj prime. Alright, now if I multiply this equation y equal to xj beta j plus xj beta j plus epsilon, by multiply both sides with 1 minus hj, then what do we get? Then we have y minus hj y equal to I minus hj xj beta j plus I minus hj xj beta j plus I minus hj into epsilon. Okay, so this one is nothing but the residual when y was regressed on all variables except xj. So this, according to our notation, this will be E ei j y, right, and this one I minus hj, this is actually ejy, sorry, this is ejy, and this one is actually the residual that is obtained when xj is regressed. So this is what happens in step 1 residual, and this is actually step 2 when xj is regressed. Sorry, this is not step 1, step 2, this is step 2. Okay, so this is what happens when xj is regressed on the other variables. So then this one actually becomes E x ij. Okay, this is actually exj plus, let us denote this by E star. Now this one becomes what? This becomes xj, if we take xj inside, minus hj xj into beta j. Okay, now h into x is how much? Hx is actually x transpose x inverse x transpose again into x, which is actually x transpose, sorry, which is actually x. So hx is always equal to x. Therefore this one is actually Eyj equal to xj minus xj into beta j plus beta j exj plus epsilon star. So what do we have? We have here Ejy equal to beta j Ejx plus epsilon star. Therefore, regression of this quantity versus this always has a slope of size beta j. So slope is actually beta j, and that is the answer. Alright, so with that we have come to the end of our session. If there are any questions, please post it in the discussion forum. Thank you so much for listening.